Sounds good.
Perfect. All right. Welcome everyone, and happy Thursday. Welcome to yet another Devpost build session. My name is Darlyze Calixte. I'm probably new to many of you. I am the new developer marketing manager here at Devpost. I've actually been here officially 1 month today. So yay for me.
Congratulations.
Uh, thanks. So get some claps, get some thumbs up. Happy to be here. Really excited for this dev session that we have today. So we have Rich Young here from Arize AI, who's going to walk us through how to get from zero to a traced agent in 5 minutes with Phoenix MCP. So if you're building for the Google Cloud Rapid Agent Hackathon, not sure where to start, or maybe you've already started, maybe you have some bugs, you kind of need to work it out, this is going to be the place for you. So a couple of housekeeping, use the chat to also chat with your fellow builders. Drop like a wave, give me a thumbs up as well. If you have questions, there also is a Q&A panel. If you are on a laptop or if you are on mobile, that should be towards the bottom in the menu. You'll see Q&A. You're also able to upvote questions from other builders and add comments. And so if somebody asks a question that you're like, oh man, that would be really great if you answered that, you can upvote those questions. And if you have a question that you're actually wanting to maybe talk about out loud, you can always raise your hand and we can bring you onto the stage as well. So I'm really excited to hand this over to Richard. I won't delay any further. We're going to jump right into it. So without further ado, Richard Young.
All right. Thank you so much. All right. Let me just share my screen here. Hi, everybody. Thank you for participating in this hackathon. I think it's great. Just to introduce myself, my name is Rich, and I am the kind of the leader on the partnerships for Rise. So I'm kind of more of a technical, have a technical background, just been working in observability and AI for several years now, and really just here to support you guys in the hackathon and your integration of Arize. So I figured I'd start with just a quick overview of kind of what Arize is. For a lot of you folks who may not have heard or used Arize, Phoenix, which we're going to use for today's example, is our open source product and tool, which is kind of great for hackathons and developers that are looking to really just kind of understand agents as we're building them and making them and try to make that a tool that you can use to make them more successful in your testing, iterate and improve those agents, get that feedback, which is really important because as you move kind of from these projects, which we're kind of focused on, to more kind of production ready um, applications, you need kind of that really kind of important feedback loop. So Phoenix is kind of our open source, tool that's really easy to get started. I'll cover some of the different ways that you can leverage it in the kind of this project, and even like post project using that and running Phoenix locally and just running that, and we make it really easy for you to kind of download and use it as necessary. So I'll give you a quick overview of Arise and then a little bit about Phoenix. And then we'll jump into the GitHub repo, which is kind of the main focus of today, as I want to kind of just walk through how do you get started. So I created just a really simple agent based on a Google ADK personalized shopping assistant that I pulled off their repo, have it kind of set up here. So hopefully this is something you can just easily walk through. I'm not going to kind of go through too much of the agent code, but I'll kind of show you what the instrumentation process looks like to get traces, instrumented, traces out of the agent. And I'll talk a little bit about what that looks like, and then into Phoenix. And then I'll also talk about kind of our MCP tool, which you can use with Phoenix. There's also the skills route, and I'll talk through kind of like kind of a little bit of best practices to kind of get set up. So the one difference I will point out from the repo that we provided was this only focuses kind of on the MCP installation, but since the publishing of that repo, we've done a lot of work and a lot of kind of work to make to use skills as well with kind of any of your coding agents and assistants. So this is really great tool. I recommend we'll kind of go through the recommended setup so you can kind of go a little bit off script on the repo and just kind of install all three. I recommend that. And you'll find a lot of really cool use cases for hopefully this exposes you to skills in using our tool to improve your agents and kind of get insights and just kind of automate a lot of the workflows that you'll see kind of on the self-improving side. So I'll touch on that. And then I think that's kind of what I want to mainly cover. If you guys have any questions, feel free to jump into the chat, and I'll definitely leave some time afterwards so we can go through some QA. All right, so let's get started. The first thing I want to do is just kind of give you a quick introduction into Arize. So Arize is the leader in, what we used to call AI observability and evaluations. The space is moving so fast, as you guys all know. And a lot of the tooling around the area, it kind of gets confusing because observability is kind of a generic term that's used. It's been around for a while. Um, and I actually have a background. I came from the early days of Splunk. Tracing distributed applications and tracing in general is kind of a key core concept and kind of a data source or data type, I would say, of what's really used in today's kind of like observability platforms. But we really consider ourselves, Arize, to be an AI engineering platform because it's not really about observability anymore. Just a quick touch on Arize. So we are about a 6-year-old company now. Got started in machine learning and actually kind of like machine learning observability and monitoring. So we do have a lot of companies here, as you can see across the board, that we can cover kind of like on an ML monitoring use case, but also very heavily, a lot of the focus is now on agents, LLMs, as you guys know. That's where the puck is headed. So we really can cover kind of the full suite of like a single platform of ML and Gen AI based observability. So yeah, lots of really great customers. Also big on the open source front too as well. We produce a lot of like research in the area, best practices, thought leadership. So let's just talk a few slides, and then I'll kind of get into the core of the session here. But I just want to talk about like why observability, sort of like how AI engineering sort of came about, right? So if you look at kind of traditional software engineering, that's been around for decades now. It's really, followed a kind of linear process. You'd kind of build your product, you would test it, then you would deploy it into production, then you monitor it, kind of a standard process for kind of your typical development processes. And that was great because this whole process was really based on a deterministic kind of outcome, right? You could effectively look at your code, understand what your application is going to do, without having to, and you'd basically revert to kind of logs or metrics to kind of understand, post after you push it to production to see where things are breaking. Like things like, 500 errors, things that are long running or latency starts to spike or other kinds of more system errors. That was great because everything was deterministic. In this new world of AI and kind of LLMs in general, everything is really kind of non-deterministic, right? So things like different tool calling, the agent decisions, the responses, right? Those all can vary based on the same inputs, as you guys know. So that can create a lot of uncertainty, right? So your failures in AI quality can actually be very silent failures. Answers can look great, but might be hallucinated, as an example. Might call the tool, right? Wrong tool, and that can cascade down if you have these multi-agent workflows that cause a lot of these bigger issues that are compounding that kind of thing. So the new process that we see is really this kind of continuous loop of improvement. You need observability to collect the same type of data. And in this case, we collect trace data. I'll show you what that looks like. Um, we then run evaluations on that. So this can be like an LLM as a judge or code-based evaluation. So that can check the output of your responses, your tool calls, et cetera, right? To validate whether those those are individually correct or maybe at a trace level or even a session level. And then you take that signal that you get off of the traces and then use that as data sets, right? Regression data sets come out of that to understand where did things fail, and then you use that to then improve, right? So this is really a continuous cycle of improvement, an iteration cycle, if you will. And so that's really where Arize shines. We see ourselves kind of, in the middle and helping to really automate this loop as a process here. So that's really the biggest change in software, in decades that we're seeing right now is this concept of agent engineering, right? Platform. And this feeds into this overall idea of self-improving agents, right? So the concept is that when you have your agent kind of out in front of users, we are collecting that data in the form of traces. We are running evaluations on that data. We're querying that data to basically filter on the regressions, to curate data sets from them. And then what you do is design and run experiments that sort of try to fix those errors or change the scores, right? Based on, if you've got 100 regressions where the agent picked the wrong tool, for example, you want to see if there are different prompt changes or model changes or something that you can change in your tool definitions or something in the agent specifically in the configuration, and do maybe A/B testing across those to see how that addresses that score and if that improves the score. And then, once you land on a ideal situation or things, you see that improvement, that is the configuration you push to production. And then because your agent is instrumented and collecting data, it kind of goes back through this loop, right? And so as you'll see with Arize and which is our Arize AX, which is our enterprise product, and Phoenix as well, you will see considerable like improvements. Coding agents are obviously, becoming big. I'm going to touch on that a little bit here. So if you guys are working and leveraging coding agents to build agents, you know that the agents themselves are actually replacing the human element in this loop where humans used to be the ones that looked at your data, figured out what kind of evals you need to create, curate the data sets. The coding agent is starting to automate and be the hands-on keyboard, so to speak, to execute a lot of this. And so Arize is really looking to be kind of more of an evaluation agent harness around that. So we equip the coding agent, we equip the human with tools, right, around being able to access this data, run experiments, and get the feedback to automate this process. And that's why it's becoming more and more automated and self-improving over the time. I think I'm going to just skip over this stuff and then jump into Phoenix and Arize. So just a quick note, Phoenix is what we're going to focus on today. That's our open source tool and allows you to kind of, get traces in and have kind of a UI that you can look at around the tracing observability. Allows you to create and use evaluations to run on that data and then do a lot of the experimentation as well, right? And run experiments offline and then sort of post them back so you can monitor the progress. And so Arize is going to be more of that enterprise scale. It's more of a paid product. It's something that is really once you are in production, we cover things like production level monitoring, alerting. We have an in-house co-pilot called Alex that sits along and helps kind of like automate a lot of the processes. So you can, if you're interested in Arize AX, you can always go to our arize.com and sign up for a free trial and get your hands on that to try that as well. So a lot of really cool features. I won't go too much into that today. I'll focus on Phoenix. All right. So that's kind of the high level overview. So what I want to do now is jump into our hackathon repo that I kind of published here and I'm going to walk through that with you folks. If you have questions, yeah, go ahead and put them in the chat or I'll kind of, or I think there's a QA. Is there a QA thing? Okay,
Yeah,
I'll
there's a
try to
QA.
monitor. Okay, if I'll try to monitor if you see something pop up with questions, Darlyze, just bother me as well, and I can
I
jump
got
in.
you. We already have a couple of questions, but if you want to go through what you're doing first, and then we can get through those. We have like five.
Yeah. Okay, no worries. Perfect. Yeah, you guys might be further along, so I'm gonna try to do an overview and then we can answer the questions here. So what I did here, just to kind of point folks to, is there's a repo we created that you can use as a starter for getting traces into Arize and sort of getting started with our CLI and our MCP service, our MCP server. Okay, so kind of the first key thing that you'll probably need to do is in Phoenix is to get the traces into from your application as you're building them into Phoenix. So some prerequisites here. You can see basically you need Python, UV to install and just run it. And then you will need access to Google, obviously, and this is kind of what I'm using, but if you're using different models or anything like that, you can use a different approach. But here I'm going to be focusing on Google. So we have different auth mechanisms here. I'll touch on what the environment variables look like when you're setting this up and kind of what I did to set this up, and I'll walk through the demo live. Um, so everything's set up on the agent code. I'll walk through what that looks like. But basically, you're just going to kind of change environment variables. And the things you'll need to set up are the API key. You're going to need a Phoenix collector endpoint, and then your Google API key or Vertex AI settings. I'm going to flip over my screen here just to show what I have in my environment variables. So in the repo, you're going to need a .env file. And what I have is I'm using kind of the more common Vertex AI path. So this is where you just need to set up these environment variables, set up a project that has access to Google models or Gemini models that you can use to test. Need to be something you need to do on your own and make sure that you have access to, and the project is set up there. So you really kind of just set this up, and then there's a command you can run on the command line to basically authenticate, and it'll use this project to then access the models right when you're testing in Gemini or what have you there. The only pieces you'll need for the Phoenix setup. So Phoenix is basically a service that's running. You can run this actually locally, but in this example, what I'm going to do is try to keep it really simple so you don't have to install or set up any software on your side with Phoenix, although it's really easy to set up. I'm using our SaaS here. So basically, the endpoint that you're going to use, you can grab from the settings in Phoenix once you kind of register and create an account there. And then the URL will look like this. It'll just be an endpoint and then something /s at the end with I think it's your username that's appended to the end of this here. And then you'll need to set your project name. This project name is whatever you want to create. It's more of a kind of a name or placeholder for kind of where your traces are going to show up in Phoenix. So this is really all you need to kind of like set your environment variable to set up. The other thing that you will need to do is set up your Gemini, if you're using Gemini, the settings here. So this is basically, I kind of put in the path here, what you need to configure this here, but basically it's a couple lines in JSON here. And if you kind of just do a copy and paste of, I think, somewhere in here, we should be able to get that to, yeah, in the repo, I think in the example, you'll see something there for that. Um, and you need to put that in there. The other thing you can do is just make it easy on yourself. And in our docs here, if you go to rise.com docs Phoenix, um, and then do a search for like coding agents, maybe in the search text box, or go over on the left-hand side under getting started. If you click on coding agents, this actually, I would recommend going this route if you can. Um, You'll just follow these. What this will do is actually install three things for you. It's going to install our MCP server. It will also install our CLI and our skills. So you'll really have full capabilities. There's a debate right now whether MCP and skills, like what's the better route to go. My opinion is that skills is a bit easier to kind of install. These are just like MD files basically that give your in a directory somewhere, and then you point your coding agent to it, and then it kind of learns how to use whatever skill you tell it, right? It's a little bit more easier than kind of like installing an MCP and all this. But there's kind of different ideas around that. So we support all three. The CLI is really kind of the backstop to the skill. The skill is really just an instruction to the agent itself on what it can do and when to use certain tools. And the CLI is really the tool it's using. So the CLI is just terminal access to access the data that's in Phoenix, to be able to, and then some certain skills to basically execute certain commands like you can see here, investigate tracing failures, inspect and compare experiment runs, fetch data sets, right? So there's kind of like you can just natural language prompt it, and these are going to execute different commands on the back end to get your data. So really for this setup, you just set up your environment configuration for these items here. I'll show you how to get these, and then you follow the process right here. Just sort of copy and paste these install commands. This will install the CLI as the first step, and then you can run this command if you want to set up the MCP. And then the last thing is skills here. So there's kind of three things to install. And with that, you're going to be well covered to be able to have a lot of power around being able to access and do a lot of things in the application. All right. Let's see here. So I think what I want to do now is talk through the code here. So tracing, I'll touch on tracing real quick as a concept here, and what it basically is to set this up. So I think in our docs as well, there is, if you're new to tracing in general, let's see if there's something good here. Um, yeah, overview of tracing is a really good place to start in our documentation. If you're new to tracing, we are first and foremost open source and built on a standard called OpenTelemetry. OpenTelemetry is an industry kind of format for tracing metrics and logs. It allows you to be kind of agnostic to technology stacks and different platforms, right? So anybody that most platforms these days that use OpenTelemetry are compatible with each other. It means you can send traces from other places, or even from our platform into other platforms, and they should be able to receive that as a transport layer. On top of that, we actually uh, Arize authors Open Inference, which let me see if I can bring this up here. And Open Inference is um, built on OpenTelemetry. It's also open source, but this actually gives you the ability to auto instrument all of the different, depending on what you're building in. And we're focused on Google and ADK today, but we have an auto instrumenter for ADK, for example. But as you can imagine, there are many frameworks, there are many ways to build agents and different kinds of LLMs. We want to be agnostic to all of those things and give you very easy ways to basically auto instrument and get data out, right? So this is kind of our library of open source kind of auto instrumenters. We're constantly updating and adding to these all the time. So as new frameworks and new language updates come out, we will have new libraries here to make it very easy for you. And I'll show you what that looks like in the product. All right, so to set up, so just to kind of show, I'm going to run the agent itself and kind of like show you I'll follow the process here and we'll just run a quick example. But really what's happening under the hood is there's an agent folder here. And in this folder, the main.py is basically kind of our main Python, file here. I'll walk through what's happening here and I'll show you what's basically being set up. So we have our agent, you know, details here. There is let's see. So this is a single turn where it's taking in a user query or question, right? The user input, and there's a setup tracing here. Basically, that's through this instrumentation import that I'll walk you through real quick. It's really doing very little there, but it's that's where the instrumentation is happening. All the other code here is basically executing the agent as is. There's nothing specific about Arize instrumentation. So there's just a instrumentation Python file that's set up here. And so this is kind of where the magic is happening. Kind of ignore all this. Really, all we're doing here is we are setting up this function. So from Phoenix OTel import register there's a register convenience function that we're passing that basically wraps our OpenTelemetry setup so that you just need to pass in this detail. And this has basically the project name, right? It's either going to grab a project name if you have one set up as an environment variable, or it's just going to use this Gemini Hackathon out of the box. And then the auto instrumentation is set to true. So what this is actually going to do is it's going to go through your source code and basically, or it's going to look at kind of your code and scan it and see what type of um, SDKs or frameworks you're using, and it will pull in and the right instrumentation packages and basically auto instrument everything for you. So that is super convenient because you don't have to specify what you want to kind of instrument, right? But you can do that manually, of course. Um, you can look at our docs and kind of see how that's done. But basically, this is all we're doing to set up the instrumentation, right? In the agent. So if I go to, let me actually go into terminal now. See if we can get started here. All right, so I'm going to get out of this. All right, I'm in my repo. So this is the repo I'm at for the repo I just downloaded locally and running this. Let me actually go back here and see if I can run this locally. Okay, so I have this. Okay, so I'm just going to run the agent itself using this. All right, so this should go through and run through. You can kind of ignore some of these warnings. This is basically just find the right protocol. Okay, so looks like it ran okay. So what happens now is in this example, we're just passing a query in. It's doing a bunch of stuff in the agent under the hood, and then it executes the instrumentation that I saw that I just kind of showed you is now capturing every single thing that's happening in the agent, and it's sending it to Phoenix, right, via these um, settings that I set here, right, in the environment variable. So let's see if I go into Phoenix now. So now I'm in Phoenix, and in Phoenix itself, it is sending to this project called Gemini Hackathon Starter. That's what I've called it. And so if I click there, you should see the latest one here, 10:30. Yep. So this is the one I just executed here, and there's a trace for it here. And if I click into it, you can see there's the question I asked, and then kind of some output, right? That's had output. And then these individual spans that you see down here are things like LLM calls, right? Executing a tool search for probably searching for, finding, in this case, it's finding specific products. You can see the prompt, the system prompt here, the model lookup, and execution of the tool search. And then I think there's two LLM calls here. The second one looks like it is kind of putting together some kind of a response here. So those are all the steps and everything that's happening. And you can see in these input messages, I can click on tools or just other kinds of tabs here. You can see all the things that we capture at every step of the process. These are why we call them spans, because spans are like a unit of work, and a trace is the entire unit, kind of the entire transaction or the user response request of things that are happening. So these are just kind of different terminologies you would use around tracing itself. Um, cool. So I think I showed kind of the execution of the agent and what you should see if you set up, from the repo itself and how the instrumentation actually looks like and just kind of what that is under the hood. To get some of these values, some of the questions are, all right, how do I get my, Phoenix API key and the endpoint, right? So the thing, if the first thing you'll need to do is set up a Phoenix account on our SaaS account. So let me see. In Phoenix Cloud, I'm already logged in here. So what you do is if you go to app.phoenix.arize.com, I think that link itself will take you to our SaaS platform. And then if you want to sign up or register, you will do that. And then once you have that in, I typically use like the Google authentication and just use my Google um, OAuth to kind of like to sign up for an account. That's what I did here. And once you do that, you'll see something similar here. And what you'll want to do to get your URL is to, let's see, oh, here's my space. Sorry, should have ran this earlier. So this is my space. And then in every space you can create as many projects as you want. And these are different projects that you set. So every time you send traces into Phoenix, you're going to give it a project name, and then that project name is where those traces get sent to. That's what you're seeing here for these other ones that I have here. To find your keys, you would go to settings down here on the corner on the bottom. And this is where you'll find the host name. You'll need this because you need to specify in your configuration file where to send those traces, right? That's what I have here. So if you look at the host name, you just copy it over and plop that into your collector endpoint here. If you're running this locally and you've already kind of like set this up, you're going to have a different endpoint. You're going to have your local host endpoint here running in place of this SaaS endpoint. But for this example, I'm going to use SaaS. And then the other thing you're going to need is your API key. So here is your API key is typically found. It's called secrets now. Okay, so I believe this is where it is, secrets. So actually, let me double check. Oh, never mind. It's not secrets. It's API keys right here. So right under host name, there's an API key here. We have the concept of system keys and user keys. I would just use a user key. Click on this top corner here, and then just give it a name, right? Give it a name, and then create the key, and then you'll have your key here, and that's what you're going to copy over to uh, the config file as well. Those are the only two things you really need. You can give the project name, like I said here, and then that becomes the project name that will override the one that's in the instrumentation setup. And I think that is the most important thing is just getting this set up in the example or in your agent when you're setting things up. You typically need those two things to get started, right? And get data into the platform. Once you have traces in the platform, then you can take advantage of the rest of the features, which we'll go into in a bit. Okay, let me actually take a quick pause here. I want to make sure that folks are not having any issues here. So let me actually quickly check the QA and see.
Yeah, I've got a ton of questions.
Mhm.
So we could probably take them one by one. First question being, when given an LLM access to external tools via Phoenix MCP, how do you prevent or evaluate tool call hallucinations? And then what's the recommended Arize Phoenix evaluation pipeline to benchmark tool execution safely before pushing to production?
Hmm, that's a good question. A little bit probably more complex than I think I'm prepared to kind of like demo or sh share here, but I can let me actually kind of answer that at a high level. So we have a set of really good evaluators out of the box here. Let me go into my docs here to kind of show that to you. I would recommend using some of these to get started. Oops, this is Arize docs. Uh, so we help you get started with kind of out of the box evaluators for very common use cases like you're talking about there. So tool execution, hallucination, validating the correct tool choice is kind of a very common use case. So I think, let's see, what was a judge? Okay, so in our docs and under evaluation, you can probably go through either the overview section or kind of one of these pieces here. What we have is, let's see, we do have like out of the box evaluators. Let me see if I can find where that is. No, that's not it. Sorry. Sorry. There we go. Got it. So built-in eval templates give you access to kind of like some ones that we have here. So in the docs, you'll find our evaluation templates here. There are a number that you can use. Tool selection and tool invocation, tool response handling are kind of like three that are really easy to use out of the box. That can give you really good coverage for hallucinations around tool selection. And that's the first step is being able to run these evaluations on the spans where your LM is picking and choosing the right tool. This tool selection is a check to see if the right tool is selected. So given a set of tool and your tool definitions and the user query, it will look at your user query and analyze the definitions and see if it logically chose the right tool. Tool invocation is actually checking to see the other piece of this is to check to see if your tools were called properly. So it's not about just picking the right tool, but did you pass the right arguments to it? Were they formatted correctly, right? Is the data, correct that should be passed in, that kind of thing. So we can evaluate that automatically as well as a kind of a second step. And this actually is tool response handling. So this is kind of, looking at a little bit more things around error handling, data extraction, etc. So that can give you kind of some good starting points there.
Nice. Thanks
Um,
for that.
yeah, no problem. All right, self-improving. I'm going to go to the next one, I guess.
Hmm.
Since we're talking about the self-improving loop, how do we practically close the loop automatically? We can use Phoenix as a trigger dynamically as a bad prompt iterations. Yep. So you're kind of talking about a lot of the self-improvement process here. So I think I talked about the concept that you collect your traces, you run these evaluations on them. In Phoenix, you're going to typically do that via the SDK offline. In Arize AX, you actually can do that online in the platform automatically. So I would follow some of the processes around being able to run experiments. So let me show you that here. Some of this is going to be, so conceptually, what you want to do is you want to um, I would look at this page here on datasets and experiments. The idea is that you collect the data, you run the evaluations as I showed you before, for example, checking the tool call, and then that's going to create a label on your data, which you can then create the data set from. You can then run an experiment on it. So this is kind of where you can either have, if you're trying to automate completely with maybe a coding agent, or if you want to do it yourself, you'll look at the data and say, okay, let's try to optimize the prompt as a kind of a simple example, right? Um, Maybe taking the failures and the evaluation labels that are created, and then looking at that and having your coding agent actually create a prompt from the failures and say optimize that, create a better prompt for it, and then test that prompt, right, using the experiments workflows here. So that experiment workflow will kind of do an A/B test, and then you'll be able to see in the scores once you rerun the evaluations on that new prompt change, whether the prompt improved or not. In Phoenix, we have this data sets and experiments section. So when you run your evaluations, when you run your experiments, that will create an experiment that shows up here. And so what you can do in Phoenix is actually track the improvement, right? You can check the scores for your detail here. So like in this example, I have a data set of I'm looking for basically intents that are of different inputs or questions. So these are all different kinds of questions, and they would have a different class of kind of questions, right? Intent classification is what I'm doing here. Uh, Ran that experiment offline to see if the output is correct, and then basically you can kind of inspect, right, the output and the response and also the score here. So this is what you're seeing here is just intent correctness as a score. It's 100%, which means that like every one of my 4 or 5 examples that I ran here has a output the from the A/B test or the test itself, and then here's kind of the correct answer. That's the golden answer that it's validating against. So that's what my evaluation is testing there. So you can run these evaluations or you can run these experiments either through the coding, asking the coding agent to do that. We do have some examples of that, I think, in the docs. That can either be done here or you can actually run experiments in our playground here as well. So the playground gives you kind of more of a human way of kind of testing different prompts here. So we can bring in, for example, let me see if I have one saved. So I've got one here for my uh, intent classifier. And what we can do is, this is like my A prompt here. I can do a compare and pop open a B, right? And I can maybe change my prompt here or try using a different model here. Let's see if it actually has, where do I change a model? Yeah, so here I'm using GPT-4. I might want to pull in, a different model here and test a different model against that model and then be able to run an example. So this is where you can test these two prompts. Let me see if I can bring in my data set here as well. I can do that. Uh, should be able to do that here somewhere. So yeah, and basically you bring in your data set. There we go. Um, and run those side by side. So when you run this, it'll kind of allow you to compare the results side by side. And then you can actually add an evaluator here. I don't think I have one here, but you can create one and basically have it and run it, and it will automatically run the evaluations on this playground. And then that will actually show up in your experiment here, going side by side. As you can see, it already did. Cool. Hopefully that was helpful.
Definitely helpful. All right, next question. Since Phoenix MCP runs inside the Gemini CLI instead of the Python ADK process, how does it handle session state context if the user switches projects mid-conversation?
That's a good question. I can only say from experience uh, that the context that it's working on in your project will get lost if you have to kill the session, essentially. So there's not a good way to kind of like be able to kind of switch between that. Unfortunately, that's at least that's my experience. I can check and see if that's actually a good question because I think that comes up a lot, not just in CLI, but like in other coding agents as well. Yeah.
All right, we'll flag that. We'll come back to that at a later date.
Hmm.
Someone asking the role of an AI agent engineer. We can talk about that later in Discord. But next question for the Gemini Hackathon Starter template, if we want to scale from a single agent loop to a hierarchical multi-agent system using the Google ADK and Phoenix MCP, does the
Yeah.
current initialization setup automatically trace the cross-agent delegation, or do we need to manually pass down the trace context?
Yes, you do have to pass trace context down if you want to get visibility into the kind of the downstream agent that you are capturing. Um, you only get trace data out of what you are able to instrument in
Mm,
Arize. There is so OpenTelemetry has this concept of context propagation that is built into the feature itself. There in our docs, we do have under like more of the advanced section of tracing, we do have a some instructions on how to do that. I can look for that maybe and pass that along in a follow-up, but basically that's how you would do that if you're working in multi-agent systems where sometimes you have control over the other agent you are accessing, maybe not, but if they are tracing, you can pass context between them that way. So that's a good way to do that.
good to know.
Good
There's a
question.
question in the chat. Since this starter template uses a tiny in-memory catalog, can we easily scale it to use custom vector databases like Vertex AI Vector Search while maintaining the same open inference tracing spans?
100%. Yeah. Actually took the I think the example that I based this on, actually I kind of forced it to basically do use the in-memory stuff just because I wanted to be really lightweight. But there's
Mm,
a lot of databases and knowledge bases behind the actual real example. If you want to click, there's a link on that one that you can go to and access that. And ADK has a lot of really good examples. I just picked one that was try to be as kind of easy as possible for kind of like this example. But yeah, there's so many good examples in their repo. I would just go check that out.
all right. Next question. Seeing, okay, and thank you, Yash, for going ahead and answering it to some degree. But well, someone says one challenge I'm thinking about is maintaining evaluation consistency across multiple AI agents. From your experience, what would be the most important thing to improve on early in systems like this?
Sorry, I didn't see that question.
That's a
See if I
little
can-
bit in it's in the Q&A a little bit further down. There was one I skipped around, like using an iPad, which we had the community go ahead and answer. So I'll actually
Mhm.
put done on that to
All right,
kind
can you
of,
just
there we
summarize
go.
the question real quick? I didn't catch it.
Yeah, so the question's asking, basically saying they're thinking about maintaining evaluation consistency across multiple AI agents. So from your experience personally, like what would be the most important thing in terms of improving systems like this kind of early on in the process?
Mm. Yeah, good question. That is, it's really going to be different how you benchmark your results. Everyone is starting kind of at a different place, so it's hard to give kind of a general thing. The main important concept is that this is an iterative process, right? So wherever you start, even if it's like, I don't even have an agent, I just have a prompt, or I don't even have a prompt yet. I know kind of what I want to build, and I'm starting with an LLM and a user question, a set of kind of user questions. I want to build an agent that, answers chatbot or like a chatbot, a RAG chatbot or something specifically for something. You start with a data set of those questions, and then you build kind of some initial kind of grounding of your functionality, and you start with the baseline there, and you basically are just iterating, right? So um, the important thing is to have a framework where you can start with whatever it is you're going to start with, be able to understand what the performance is for that based on what these evaluations are kind of like the is your bar for taste and what is good, right? What good looks like and what bad looks like. And having that and starting there and then sort of iterating on that is it's going to be a constant process. Um, so best practice is from what we've seen is really getting started and having an initial baseline and sort of capturing and documenting that or sort of being able to capture that so that you can see the progress and chart that. Because you can't measure what you can't track, right? Or what you collect, right? Initially and measure. So those are important things to have.
Nice. I'll ask some questions in the chat just so I'm not answering just two people's questions.
Yeah,
So
thank you.
someone asks, how does Phoenix know the data structure of the tool use?
Good question. So it does. You actually provide it with kind of tool definitions. So Phoenix itself, like in this playground, you can provide tool calling. I think it's here. So you can define your tool definitions. There we go. Yeah. So there's JSON here where you can basically plug in the different tools and um, the name of the tool, the description, right? This is typically how you were going to define that anyway, right? In your agent. So you would provide that here, and then the LLM will actually refer back to that JSON as to what tools it has access to and what the definitions of them are, and when to call them, that kind of thing. So that's what you would do is apply that there. And then in the evaluations, the same thing. So if you look at kind of like the evaluation code as well, it will give you you can basically plug in tool definition as an input into your evaluation so that if you want to evaluate whether this LLM called the right tool, you can provide it with that and ground it in that as well in the same way.
Mm, good to know. All right. We have about 8 minutes left, so I'm trying to get through as many questions as possible. Does adding open inference instrumentation to a small Google ADK agent add any noticeable latency during the initial tool calling phase, or is it pretty much fully asynchronous?
It is fully asynchronous. Yeah, it's not going to change it doesn't sit in the path of your code execution. They're mainly just um, asynchronous callback functions. So they just kind of execute in the background. Very negligible kind of stuff that's been around for decades. So this has been around way before LLMs and kind of what we're building today. This has been around in distributed applications for, I think, the past 10 years or so.
Got it. All right. Someone asks, where do you recommend to host a live project? And is it better to use local or Cloud Phoenix in a live version?
Mm, good question. So SaaS. So I think if you just want to get started, like Phoenix is great. Like the SaaS is great because you just like basically sign up and it's the same application. I would run it locally if you want to start. Well, there's two things. If you don't want to send the data right anywhere, having it run locally is probably your best option there. It's also more convenient. You can use it. You can actually kind of like use it across different projects and sort of as you grow, right? You can easily grow into Arize AX as well from that as well. So I would probably, if I was working out locally, I mean, as kind of a developer, I typically just run it locally. But if you just want to sort of like get started and not have to deal with setup and installing software and running that locally, then SaaS is a great option.
Thanks. All right, 5 minutes left. Probably have time for about two or three more before we got to
Mhm.
wrap. So, native drift handling. So, how does Phoenix natively handle data drift or concept drift for text embeddings and predicted intent labels in a live production stream? We'll start there because there were like multi levels to this question.
Yeah, it sounds like. So when you're talking about drift, I'm gonna assume that this is more of a ML type of scenario. Like,
Mm-hmm.
are you talking about? Let me just kind of take a look at that real quick.
Mm-hmm.
There's
That's
kind of
further
two ways:
down in the Q&A. Mm-hmm.
faithfulness to real time
From Apergita.
models. Oh, okay. So, I mean, there's kind of like so drift. I kind of think of as more like machine learning type of use case. Um, I know in Arize AX, I think in Phoenix as well, I think we do support embeddings as well. So we can ingest embeddings and do a we can look at drift based on kind of more RAG type use cases. Let me actually check and see if we do here, just because I don't want to. Um, I think distance. Okay, yeah, I think we do this here. So this would be more for RAG use cases. So I'm not sure if this fully applies to kind of your question, but one thing we can do is we can ingest embeddings around your knowledge base content, and this can be used in I'm just going to give you a use case of like, say you have a vector database of answers, right, that you've chunked and you're supplying back, right, and you're returning those in the lookup, and and then you're feeding that to your LLM to respond. We can actually take the embeddings for kind of what's in your knowledge base, and we can also take your user queries as embeddings, and we can put them in a space here, and then allow you to score kind of drift or distance between two different bodies of text, right? And so what this could be useful for is being able to kind of understand your data in your databases and understand kind of like how your user queries are related, or maybe distance using kind of semantic similarity searches and cosine similarity, that kind of thing. So it gives you an idea of how well populated your answers are to those questions. Maybe you need to augment your knowledge base, or maybe the type of questions that your users are asking, you can understand how these questions are not relevant to what you have, right? If you have a big distribution of those types of questions. So this can be used in that use case as well, and we can actually use them here. And I think in this use case, this is actually used also to allow us to kind of other kinds of evaluations and drift between these things. So it can be used, yeah, I guess it can be used in a lot of different ways, but those are two examples there.
Got it. All right. Last question that we'll wrap. But before I ask this last question, I will ask my own question on if people have, because there are a lot of questions, if people have additional questions, what's the best way to connect with you all at Arize on, yeah, what questions that they have?
Yeah, it's a good point. So if you do have questions about the hackathon or anything like that, I'm definitely here to kind of support you. I think I don't have a link to the page, but I think my our contact information is there. I've gotten a few emails from folks that were kind of stuck, and I was able to help them block them. So I know we don't have only have an hour here, but if you guys are working on through anything and do get stuck, you can reach out, and I'll definitely work with you individually to try to make sure you're unblocked.
Sounds
So
good. All right.
yeah.
We'll share that email, Yash. All right. And so the last question being from Yash, actually, for highly
Mhm.
dynamic multi-agent workflows where prompt templates are constantly updated on the fly or fetched from remote registry, how does Phoenix handle prompt versioning and lineage tracking in production traces? Is there an automated way to map back an anomaly or latency spike in a specific span directly to a specific commit or version of a prompt template?
Yes, you can do that. So that's all done through the experimentation process and prompt versioning. So in the platform, I'm kind of showing an example of our prompt hub, which is basically where you can store and version different prompts here. So let me just kind of bring one up. There's only one version of this one, but basically the idea is that you can, as you are testing these prompts and experimenting with different prompts, you can post these to Arize, and we will store these different prompts as well as the versions. And prompts also include not just the system prompt itself, but includes the model invocation parameters, things like that. You're going to store with with that prompt itself in this way. And then these prompts themselves are also tied to experiments. So when you run experiments in Arise, basically you have a data set, right? And then you are tying these different prompts. You can see here in the name of these individual experiments, it has the name of the prompt and the version that was used in this experiment. So when you're running these many experiments and you're trying to scale, those are all going to be tracked. And so when you run your evaluations, you have a measurement of score. The evaluation is going to give you the feedback of how successful this prompt change was or anything like that. That is all tied back. So you have complete um, an archive of essentially of a history of all the runs with all the different prompts, the versions that were used, the models used, anything that was different about it, and then you can track the changes and you can always go back. So lineage is built in. You also have traces tied to the specific evaluations themselves. So if I want to look at my trace for the execution of this experiment, I have all of the details that you saw earlier in the traces. So we capture kind of all of that information here.
Amazing. All right. That is a wrap on today's session. Huge thank you to you, Rich Young from Arize AI, for walking us through all of that amazing stuff. And thank you for answering all of those questions. So sorry for anyone whose questions we did not get to, but we'll share contact information for Rich and the Arize team after this call. But also, there is a section in the Devpost platform for this particular hackathon if you have questions. So you can ask in the discussions board as well. And also, if you have answers, this is definitely a collaborative scenario. And so feel free to answer any questions that you also find. I really appreciated seeing the community in the chat answering questions. It's been amazing to see. And quick note, if you haven't already, please fill out the feedback survey. I'll drop the link again in the chat. And so this feedback survey just helps us know how to improve, what you liked, what you didn't like, what you want to see more of, so we can continue to do these sessions. Let us know if it's helpful. Let us know if you never want to see me again. That would make me sad, but I would understand. But if you haven't registered for the Google Cloud Rapid Agent Hackathon yet, please do. The deadline is June 11th, so time is ticking. And we will see you for the next workshop that we do. And if you aren't in our Discord, highly recommend joining that as well. But we'll drop any links, any resources that were shared today, also in a follow-up email later on today. So look out for that as well. So it'll be sent to the email that you use to register for this session. But thank you all for joining. And thank you again, Rich, for doing this session with us.
No problem. Thank you so much, everybody. Have a good day.
Bye, everyone. Thank you.